Okay, this is the first of several lessons that are going to help you learn how to solve an equation. Now we're going to start with what we consider to be rather simple equations, what might be called one-step equations, and then throughout the lessons we'll move to more complicated ones. Anytime you have an equation, you have a left side, you have an equal sign, and you have a right side. The value on the left, of course, is equal to the value on the right. A problem is considered solved when it looks like, and it's right here, x is equal to a number or a number is equal to x. You're finding the appropriate value for x, which makes a statement true. If you need to solve an equation, then that means it's not in that format to start with. And you can do certain things to modify the way it looks. We're going to use in this lesson the addition property of equality. And it says if you have an equation, now this is very not concrete. This is difficult sometimes for people to look at. It says if A equals B. Well, it just means if you have an equation, there's a left side and a right side. If you want to, if you have a reason to, you can add the same quantity to both sides and it stays equal. Also, if you have A equals B, in other words, just some left side is equal to some right side, you could, if you needed to, if you wanted to, subtract the same number from both sides. You can think of this like a balance. This is your equal sign, left side, right side. They are equal in weight. You can add weight to the left side and it will stay in balance if and only if you add the same weight to the right side. Conversely, if you take weight away from the left side, it's okay as long as you take the same weight away from the right-hand side. When you do this addition and subtraction, you're going to use the rules that we've studied for integers on addition and subtraction. So let's look at several problems. All right, number one, solve and check your solution. Even though you might see the solution in your head, I encourage you to work through the steps so that as the problems get more complicated, you have a process. All right, you have x plus 2 is equal to 22. I always do this. I draw a barrier. That's my equal sign. Whatever I do to the left side, I have to do exactly the same thing to the right side. Now on the left side, that's where the x is. That's my variable, that's my unknown, and I want it all by itself. I want it to say x equals. Well, there's something in my way. There's a plus 2. I want to get rid of adding 2, and to get rid of it, I do the inverse, which would be subtracting 2. So I keep this sign, x plus 2, and I subtract 2. If I did it to this side, then I have to do exactly the same thing to the right-hand side. Okay, the reason I did it was to get rid of the added 2. Then I had to do it to both sides. Look at just the left side. Positive 2, negative 2, those cancel, and all I have left is x. Good, that's what I wanted. The right-hand side, I can use the subtraction rules, although I probably don't have to. I know that 22 minus 2 will give me 20. All right, let's look at another. Oh, it does say to check it. In my mind, checking is optional, but I will show you how to do it. The check is to actually substitute in the number that you got for x and see if you have a true statement. You have x plus 2 is 22. So you're going to substitute in 20. Is, and this is a question right now, is 20 plus 2 the same as 22? The answer is yes. So you could actually do that, or you could just look at it and say, yes, that's going to check. The check is a different process than the solution, and you may do it if you'd like. The instructions say to. That is your choice if you want to check it. All right, next problem. I have x plus 9 is equal to 17. That's an equation, left side, right side. I'm going to put the barrier. Whatever I do to one side of the barrier to change it, I do to the other side. All right, the left side is where the x is. I want the x to be all by itself. There is a plus 9. The inverse of adding 9 is subtracting 9. So I'm going to take x plus 9 minus 9 equals 17, and then I have to do the same thing, minus 9. All right, I have inverses, so that's gone, and all I'm left with is x. That's good, that's what I wanted. I have 17 minus 9, which gives me 8. You could have done keep, change, change, but 17 minus 9 is traditional subtraction. The check, you could probably do the check in your mind. Take this 8. Is 8 plus 9 the same as 17? Yes. All right, number 3. I have d minus 9 is equal to negative 19. All right, I've got my equal sign, which is like the barrier. It's like the pendulum in the scale that we looked at. All right, d minus 9. D, I want it all by itself. It has a minus 9. Well, the inverse of subtracting 9 is adding 9. So I have d minus 9, and I want to add 9. Equal sign. Whoops, let me go back to my other ink. Equal sign. Negative 19, and I'll do the same thing, plus 9. So I can see, and I've done it in red so it shows up, that I have done the same thing to both sides. I know that it is still equal. Now, did it accomplish what I wanted? Yes. Negative 9 and positive 9 cancel out, and I have d is equal to, now over here, the addition rules. I have a negative 19 and a positive 9. Subtract, keep the sign of the larger, should give you negative 10. If you wanted to check this, is negative 10 minus 9 equal to negative 19? Well, let's see. If I were going to do that, and I did keep, change, change, that side is negative 19, and so is that side, and they're equal. So it checks. All right, let's look at 4. I have d minus 9 is equal to negative 16. There's my barrier. The side that tells you what to do is the side with the variable. It has d minus a 9. I want to get rid of minus 9. The inverse of that is add 9. You're undoing the problem. So you'll add 9 to the left, equal sign, negative 16, add 9. On the left, negative 9 and positive 9, or subtracted 9 and added 9, cancel out, and I have d is equal to negative and positive, subtract and keep the sign of the larger. That's going to give me a negative 7. Let's look at number 5. I have 15 is equal to y minus 5. Okay, this time I have 15 on the left and I have y minus 5 on the right. My attention is all focused to this right-hand side because that's where the y is. It has a subtracted 5. Well, how would I undo subtracted 5? I hope you're hearing in your head, you would add 5. So I have y minus 5 over there, and I will add 5. On the other side, I have 15, and I have to do the same thing, which is add 5. So my motivation comes always from the side with the letter. All right, let's see. Subtracted 5, added 5, those are gone. I have y on the right-hand side. 15 plus 5 is 20. It's absolutely fine for it to say 20 equals y or y equals 20. It doesn't matter. Number 6, 9 is equal to y minus 5. Here's my barrier. The left-hand side has just a 9. The right-hand side, oh, there's my y. So that's what I want by itself. I have to get rid of anything that's with it. There's a subtracted 5. So I hope in your head you are thinking, then you need to add 5. So I'm going to add 5. But if I do it to that side, I have to do it to the left side as well. It feels a little backwards when the variable is on the right, but it shouldn't really bother us. A subtracted 5 and an added 5 cancel out to get y. And on the right-hand side, on the left-hand side, I get 14. Now, starting with number 7, things change a little bit. So please notice this. In these, I have variables, which are the x's, on both sides. Now, that's not a good deal, because if I went back to my original page and looked up here, a problem is solved. The final equation has the form x equals a number or a number equals x. If I have x's on both sides, well, that could be a problem. We have a way around it. We have 8x is equal to 7x minus 29. All right, you have x's over here and x's over here. I want them all on one side. Now, you can get rid of either one. It's your choice. I typically recommend that you get rid of the smaller one. That's not a rule, it's just a suggestion. And when I say get rid of, if it is positive 7x and you want it to go away, then wouldn't you subtract 7x? Okay, so here's what I'm going to do. I have 7x and I want to subtract 7x. I'm going to copy down the minus 29. So I snuck this in, equal sign. I have 8x and I have to do the same thing. Minus 7x. There are other shortcut ways, to write this, but this is a very traditional way. And you know what? I forgot the barrier. There's the barrier. I decided to get rid, I have variables on both sides, which is not going to work. I have to get rid of one of them. I choose to get rid of the smaller one. If it's positive, I subtract. If it happened to be negative, I would add. All right. On the right-hand side, I'm focused on my x's over there. I get rid of them because one's positive, one's negative, but they were the same numbers. So I'm left with negative 29. On the left-hand side, I had 8 of these x's, and I took away 7 of these x's, so I'm only going to have an imaginary 1x. Just like if you had 8 apples and you took 7 apples away, you would have 1 apple left over. So we don't write the 1, we would just say x is negative 29. When you have variables on both sides, you have to, either using addition or subtraction, get rid of one of them. That's not a mathematical way to say it, but it is what you need to do. All right, next problem. I have 11x is equal to 10x minus 17. Barrier. I notice that I have x's, I keep losing my page. I have x's on both sides. Well, that's not a good thing. You have to eliminate one of them. You can either get rid of 11x or you can get rid of 10x. Although there's not a rule about this, the suggestion is do whatever it takes to get rid of the smaller one. All right, it's positive 10x. What are we going to do to get rid of it? I hope you're thinking we're going to subtract 10x. So in red, I will sneak in a minus 10x. Finish up that side with minus 17. But if I did that to the right-hand side, then I have to do that to the left-hand side. Okay, I'm looking over here because this was where I was trying to get rid of something. Positive 10x, subtracted 10x, that's gone. And I'm left with negative 17. Don't forget the negative sign. And then 11x minus 10x leaves me with an implied 1x. X is negative 17. That's what we have to do when there are variable terms on both sides. Number 9. I have d minus 3 is equal to negative 7. Okay, I don't have variables on both sides. That's a good thing. So I focus over here where the variable is. It has a subtracted 3. If I want to get rid of that subtracted 3, I do the inverse, which is, and I hope you're hearing, add 3. So I have d minus 3 plus 3 is equal to negative 7, and I have to do the same thing, add 3. So one side, the side with the variable, motivates me to do this, but then I have to do the same thing over here. All right. Now, subtracted 3, added 3, those cancel out, and I get d is equal, whoa, sorry, losing things here. D is equal to, if I have a negative 7 and a positive 3, different signs, addition rules say to subtract, keep the sign of the big one. So it is negative 4. Remember, you can check any of these. Number 10. I have d minus 2 is equal to negative 25. All of these problems, I've been using the addition rule for equality. Either add or subtract the same number to both sides to accomplish what you want. All right, I don't have variables on both sides. I just have a d over here. What do I need to get rid of? A minus 2. So I have d minus 2, and to get rid of a minus 2, I will, that's right, add 2. But if I add, oh my goodness, I did not intend to do that. And I just have to find the lesson. Okay, I'm back. I'm so sorry. All right. So if I added 2 to the left-hand side, I'm going to take negative 25, and I'm going to add 2. You can tell these videos were not professionally made. They were just made by a teacher. All right, on the left side, I have a negative 2, or a subtracted 2 and a plus 2. Those cancel out, which leaves me with d. That's good. That's what I wanted. The addition rules, when I have a negative and a positive, I subtract. For 23, keep the sign of the bigger one, negative 23. Okay, I've just got 2 more. I skipped a couple. I have 12n is equal to 11n plus 17. Now I need n by itself, but I have n's on both sides. This is the kind where if you have a variable on the left and a variable on the right, you have to get rid of one of them. Your choice. I'm going to get rid of the smaller one. To get rid of 11n, I would need to subtract 11n, but I still have a plus 17 over there. So if I subtracted 11n from the right, I will need to subtract 11n from the left. Whoops, I did not intend to do that. All right, these 11n's, positive 11n minus 11n, gone. That equals 0. So I have a 17 left. 12n minus 11n. We'll talk more about doing this kind of work later, but I think it's logical that that would be 1n. So n is 17. Let's look at one more. I have 9n is equal to 8n plus 28. I need to solve for n, but I have n's on both sides. That's one of those cases where I have to get rid of one. I choose to get rid of the smaller one. All of these have been similar, and that's good for right now. Later on, we'll branch out. I don't want this 8n over here. I want my n's over here. So I'm going to subtract 8n. So I have 8n. I'm going to subtract 8n. And I still have a plus 28. I just snuck that in. All right, so on the left side, I have to do the same thing. I have to subtract 8n. I accomplished my goal. 8n minus 8n is 0. That's gone. So I'm left with 28. 9n minus 8n gives me 1n, but I don't write the 1. So n would be 28. All right, I hope that is a good first start at solving equations. In all of those, we use the addition property. We'll learn more properties in future lessons.